Hi, hearty welcome to you. In this session, we will go through inverse trigonometric functions. We have completed the trigonometric equations where we have looked at solving the trigonometric equations and we understood there are two types of solutions, principal solution and general solution. Now let's look at the inverse trigonometric functions and try to understand what's the concept behind that, and afterwards we'll go through some of the properties of inverse trigonometric functions to apply the concepts and solve the examples. As the name suggests, inverse trigonometric functions, we know that by default trigonometric functions are periodic functions, and any periodic function cannot be have a inverse of a function. Now let's try to spend some time and understand what's the meaning of a inverse of a function and when it will exist. Now let me say that suppose there are two data sets A and B. Now there is a function going from A to B, then the inverse of this function will exist. If it exists, it will have from B to A, and the inverse will exist only if F is bijection, or it is 1 1 and also onto function. It is 1 1 and onto function. What exactly is the meaning of that? The meaning of that is, in the bijection you will see that suppose there are elements in A, there are elements in B, then 1 1 function says that every element is uniquely mapped to the other element of the set from A to B, and the onto function says that all the elements of B will have one corresponding mapping to element in A. That means the codomain of B is nothing but the range of the A. What exactly is the meaning of that? Is that all the elements of A are mapped to uniquely in one element of B, and also all the elements of B are mapped to one unique element of A. Then we can say that there exists inverse, F inverse, which will go from B to A. Now let's take the trigonometric functions and see how we can make the trigonometric functions as inverse functions. So for that, let me just erase this so that we will look at that. Now we know that by default trigonometric functions are periodic functions, as I said earlier, and they cannot be inverse functions. But if we are able to restrict the domain of the trigonometric functions in such a way that they become bijection, then I can have a inverse. Now for that, let us simply have a look at the graph of sine curve. This is the sine curve we have. If you look at the sine curve, if you remember, when we are dealing with the trigonometric equations, we said that minus pi by 2 to pi by 2 is one window of sine which we have taken to find out the principal solution. You can see that from minus pi by 2 to pi by 2, different values of x have different values of y. There is no repetition. That means x is not mapped to y more than once and y is not mapped to more than 1x. You can see that if you draw the straight lines here and see that for each x, the different value of x will have different value of y. That is nothing but bijection. So you can see that in sine it is happening between minus pi by 2 to pi by 2. So if I restrict the domain of sine function from R, which is earlier, to minus pi by 2 to pi by 2, then I can have inverse of sine function. Similarly, you can see that if I am able to restrict the domain of cos function from 0 to pi, for that means actually you can also do it from 2 pi to 3 pi. 2 pi to 3 pi. Similarly here, instead of minus pi by 2 to pi by 2, you can do from pi by 2 to 3 pi by 2 only. Also, only the thing is we have to make sure that it becomes an bijection. That means for each value of x here, the value of y is different, and all the values of y are covered by the x whatever the values you have. Now you can see in cos, the domain is 0 to pi. If I am able to restrict the cos domain to 0 to pi, then I can have an inverse. What we are talking about is, let us try to show that in the form of functions. Now let us take first sine function. Sine function, you know, is a trigonometric ratio or function which you are applying on the angle of the function to find out the value. So here my domain will have all the values of theta. Let us say the equation is x equal to sine theta. Then here I will have all the values of x. Similarly, if I take sine inverse, in case of sine inverse, I will take an integer value, or we know that the range of sine is -1 to 1. We will take a value, and so that the range is between minus pi by 2 to pi by 2. That means in sine inverse, can I say theta equal to sine inverse of x, where your domain is x and your range is theta. So to have inverse function, what we should have in the domain and range. For sine theta, we just now learned that the domain should be restricted to minus pi by 2 to pi by 2, and the range of that is nothing but -1, 1. If you look at the sine inverse function domain will be nothing but range of the sine function, because sine is going from theta to x, sine inverse will go from x to theta. So your range of sine will become domain of sine inverse, and it will be nothing but equal to -1, 1, and the range of sine inverse is nothing but minus pi by 2 to pi by 2. Same thing we can see here in the graph for sine inverse function. You can see that if you just take only this part from minus pi by 2 to pi by 2 and exactly rotate it by 90 degrees, so that x will become y and y will become x, you will get the graph of sine inverse function. So you know the cos, you know the xy values, you want to plot the cos inverse, make x as y and y as x, you will get your cos inverse, because x gives the domain and y gives the range. When sine is converted into sine inverse function, then the domain will become range and range will become the domain. Now let's try to fill this out so that we understand this concept a little bit more. So we will try to do this small exercise where what we will try to do is we will try to fill the domain for the sine for all the trigonometric functions and also the range domain for the sine inverse for the inverse functions and the regular functions. Now let's look at here sine x. What is the domain of sine? The domain of sine by default is R, but we want to restrict it to minus pi by 2, pi by 2. Now similarly, what is the domain of cos? Cos is R, but we want to restrict it to 0 to pi, so that I can have the inverse function. Similarly, tan. Tan, if you look at tan is sine by cos. That means we will go to tan is sine by cos, and so I can say minus, what I will do. Now what will be the domain of tan? tan is nothing but sine by cos, but it is not defined wherever cos is becoming 0, because that will be undefined. When cos is becoming 0, when cos is becoming 0 when theta is 90 degrees, that means I cannot have minus pi by 2 and I cannot have pi by 2. Remaining all are pretty much fine with tan. Similarly, for the cot, you can see that cot is cos by sine. Whenever sine becomes 0, cot will be undefined. So cos sine becomes 0 whenever it is n pi, 0 or pi here. So excluding 0 and pi, all the values of cos are domain of cot. Similarly, for the secant, secant is 1 by cos. So whenever cos becomes 0, then secant is not defined. That means that is nothing but equal to 0, 2 pi minus of pi by 2, because cos 90 is 0. When cos 90 is 0, it becomes undefined. Similarly, you can think about cosecant also. Cosecant is 1 by sine. When sine becomes 0, 1 by 0 is undefined. So sine becomes 0 between minus pi by 2 to pi by 2 only at 0. So the domain of cosecant is nothing but minus pi by 2, 2 pi by 2 minus of 0. So this is the domain and range. If you are able to restrict the domain and range of trigonometric functions like this, then we can have a inverse of functions. Let us look at now inverse function and see. We will see the same thing. We will see how the domain and range will change. We know that actually the domain is nothing but range here, range is nothing but the domain here. Okay, but we will do this. Sine inverse of x. So the range will become domain here. So that is nothing but minus 1 comma 1. That is the domain. For cos inverse, similarly, it is minus 1 comma 1. For tan inverse x, so I can have tan inverse x. What will be the domain of tan inverse x? I can have all values, or similarly for cot inverse x, it will be r. For secant inverse x, you cannot have minus 1 comma 1. So I can say, you can say like this also, or how you are saying, like minus infinity minus 1 union 1 infinity, or I can simply say r minus of minus 1 comma 1. Similarly, I can also, for cosecant also, it is the same, nothing but r minus of minus 1 comma 1. Now we have seen already what is the domain. The domain of sine function nothing but becomes the range of the sine inverse function, because this is the inverse functions. Now this is a little bit important, so we will do this exercise again. Sine inverse x, the range will be nothing but domain of sine, that is nothing but minus pi by 2 to pi by 2. This is crucial. So whenever you are applying sine inverse, you will be getting the angle value only between this. And you know, you can have so many values, but if the value is angle is between these two, then only you can find out the if if the domain is restricted to these values, then only you can have the sine inverse function. Similarly, for cos inverse, the range is nothing but the domain of cos, that is nothing but 0 comma pi. Similarly, for tan inverse x, it's not valid at pi by 2, so I will say minus pi by 2 to pi by 2, excluding the boundaries. Similarly, for cot inverse, it is 0 comma pi, and for secant inverse, that is nothing but 0 to pi minus when cos becomes 90 degrees, that particular value, only that value. Similarly, for cosecant, it is minus pi by 2 minus when sine becomes 0, so that 1 by 0 is undefined, that value is not valid in the range, so that is nothing but equal to 0. So this is the table which will give you the complete idea of how you have to restrict the domain of all the trigonometric functions so that you can have the inverse of them. So in the next video, what we will do is we will go through some of the properties of inverse trigonometric functions and try to understand how to solve problems in that. To summarize, what we have gone through is, to summarize quickly, trigonometric functions are periodic functions. So by default, with the domain whatever you have currently, you cannot have them as a, you cannot have inverse functions of them. But if we are able to restrict the domain suitably so that all the trigonometric functions become bijection, then I can have inverse of them. So we are able to go through the curves or graphs of the sine function and cos function, for example, and we understood that if I am able to restrict the domain of sine to minus pi by 2 to pi by 2 or cos to 0 to pi, I can have inverse function of sine and cos. So the inverse function of any trigonometric function is given as sine inverse of. So if sine takes angle as input theta, and the resultant or the output is nothing but the values, whereas sine inverse takes the values and gives the output angle, but remember it is always in the domain whatever the restricted domain. So that is very careful, we have to be very careful about that. In the next video we will go through some of the properties and also we will solve simple problems. Very interesting topic, inverse trigonometric functions. And there are lot of formulas, but you don't need to remember any formula. Without knowing any formulas also, we can do this with whatever the prior knowledge we have. We will see how we can do that in the next video. Thanks for watching. Bye for now.